Hello everyone, my name is Timothy Murewa Joseph. In this video, I'm going to teach you calculations in horizontal projection. I've made a video about projectile motion where I talk about its theory. So if you have not seen that video, I would advise you to look for it on my Facebook page and watch it for a better understanding of this lesson. So let's begin. An object projected horizontally falls in an arc towards the ground. If its initial velocity is u, then at time t after projection, the horizontal component of its displacement will be given as x equal to initial velocity multiplied by the time taken to reach the ground, which is this equation that you can see. But in some physics textbook, this horizontal component of its displacement is also referred to as horizontal range of projectile, and it is represented by capital letter R. This is the distance it touches the ground from the foot of the projection points. So it is represented by capital letter R, and you're going to see something like this. Let me write it down for you for clarity. So when you see something like this, you multiply by the square root of 2 times the height divided by gravity. So this equation, it's also for this, which means the horizontal components of its displacement. So when you use this equation to calculate the horizontal components, you are going to get the same answer just as when you use this one. Take notes. So let me get rid of it. And then we have the vertical components. So the vertical component of its displacement is given as y equal to half gt squared. Y equal to half gt squared. Again, in some physics textbook, you are going to see this letter y might be written as h. Yes, h, which means it is the maximum height attained by the projected objects. The maximum height attained by the projected objects. So we're going to stick to this one equation. It's still the same thing, height or the vertical component, which is represented by letter y. And then this diagram explains everything that I've talked about here. This is the the object projected horizontally at a certain speed, u, which is the initial velocity, and then this is the object part, the trajectory, which is known as trajectory, and then we have the point of projection to the point at which it reaches the ground, which is known as the horizontal component of its displacement or horizontal range of the object. And then we have the maximum height here, which is given as half gt squared. Then the time t taken to reach the ground would be t equal to the square root of 2h divided by gravity, which is g. And then we have the resultant velocity v after time t. V equal to the square root of u squared plus gt, everything in square. So take note of all these equations because you are going to need them for your calculations. So let's consider some examples. Here we've got the first example. An object is projected horizontally at a speed of 15 meters per second from the top of a tall tower of height 35.0 meters. Calculate A, how long it takes to fall to the ground, B, how far it travels horizontally, and C, its speed just before it hits the ground. So we are going to apply all those equations that I have talked about. But firstly, I would like to show you the illustration by using a diagram. So an object is projected horizontally at a speed of 15 meters per second from the top of a tall tower of height 35.0 meters. So let's say this is our tower here, for instance, and then the objects, this is the object which is projected, its initial velocity u, and then it's given as 15 meters per second, and then the height of the tower is 35 meters. So this projectile, so we're going to have something like this, and then so this is the object here. So you should have something like this diagram here. Okay, so let's do our calculation here. I'm going to put the calculation at this side. So the first thing we have to find here is how long it takes to fall to the ground, which means the time it takes to reach the ground. So we are going to use this equation. And then we substitute the value that we have. So our time is giving us, so we have 2 times height. What is the height? The height is 35. Then we divide by gravity, 9.8. Let's not forget the square roots. Everything is in square roots. So let's find the value of this. What do we have? 2 times 35, so we have 70 divided by 9.8. So we do this and take the square root. We are going to have 2.67 s, 2.67 seconds. So we've got 2.67 seconds. So this is the time taken for the object to fall to the ground is 2.67 seconds. Okay, let's go to the next question. The next question says we should note that how far it travels horizontally. How far it travels horizontally. So here we have to calculate the horizontal range or the horizontal components of its displacement, and then we are going to make use of the other equation, which is this. X equal to u multiplied by t, and then our initial velocity is 15 meters per second multiplied by the time, which we have just found to be 2.67 seconds. So when you multiply 15 by 2.67, let's try to find this. Okay, so we have 40 meters. 40 meters. So we've got 40 meters here, and then this we have 2.67 seconds as the time taken. So let's calculate the last question. Its speed just before it hits the ground. So this is the resultant velocity after time t. So we need this formula for that. I'm going to say v equal to the square root of u squared plus gt in brackets then square. So this is the formula we are going to use, this equation. So I've talked about it. This so we just substitute the value. So initial velocity is 15, so we write 15 square plus acceleration due to gravity, which is giving us 9.8 multiplied by time. What's our time? Our time is given, we've got our time as 2.67. So we square everything here, and then we take the square roots. Let's not forget. So we have V equal to 15 square. 15 square, the value of 15 square is 225. So 225 then plus 9.8 times 2.67, and then you take the square root of everything here. We should have okay, 684.66. Okay, and then let's not forget the square root. We're taking square roots. Therefore, when we add this and this together, we should have 909.66, and then our square root, the square root of this value will give 30.2 meter per second. Yeah, we should have 30.2 meter per second. So this is the velocity, the speed, or if you want to call the resultant velocity, v after time. So this is how to calculate this. That's okay. Let's try another question. Let's try another question. Another question says, a stone is projected from the top of a tower with a speed of 5 meters per second, and it lands on the ground level at a horizontal distance of 20 meters from the foot of the tower. Calculate the height of the tower. Calculate the height of the tower. So again, I'm going to illustrate this using the diagram. So we have a stone which is projected from the top of the tower. So let me just draw it here for you to see. So we have something like this stone. So let's say this is our tower, and then here we've got the stone which is projected. Okay, setting like this. What do we have again? The initial velocity here is 5 meters per second. So it will travel in this path, and then it falls to the ground here. So this is going to be our what is this? This is the horizontal range or horizontal components, which is given as 20 meters. So we have this 20 meters. So this is our height, which is not given. Don't know. Or if you want to call it the vertical component, this vertical component. So calculate the height of the tower. So here we just apply the formula that we have talk about, and then the vertical component is given as y equal to 1/2 times g t squared. So we just substitute our value. So in this question, we have to take gravity as 10 meters per second square. So we are using 10 meters, sorry, 10, not 9.8. So our gravity is given as 10 meters per second square. So we're going to make sure it times the time it takes Is time given? Oh goodness, time is not given in this question. Okay, so we cannot make use of this equation for now, so we need to look for the time. I'm sorry. So our time t should be the horizontal range or horizontal component divided by the initial velocity. So we should have 20 divided by 5, and then time t is 5 seconds. Time taken. So sorry, not 5 seconds. What's wrong with me? It should be 4 seconds. Okay, 4 seconds. So let's write here 4 seconds, and then we can now make use of this equation properly now without having any problems. We don't need to find two variables at the same time. So we have this times 10 times 4 squared. So we have this. So I have to take away this cancel. So we have 5. So we should have 5 times 16. So what after 16? Okay. So 5 times 16, so should be 80 meters. So this is the vertical component, which is the maximum height. Okay. The maximum height. So h meters. Okay, let's move to another question. Let me get rid of this. So the next question. The next question is this. So we are going to practice this by yourself. An object is projected horizontally at a speed of 16 meters per second into the sea from a cliff top of height 45.0 meters. Calculate how long it takes to reach the sea, how far it takes, it travels horizontally, and its impact velocity. So this question will help you to apply all those equations that you have learned. So please practice this question and send your answer to me on Facebook page. You can write your answer in the chat box for me to see. Thank you for taking your time to watch this. Bye-bye.